Okay, can you see the screen now?
Yes, Prof, I can see the screen.
Okay, I think I've got the wrong date here, but it was supposed to be on the 29th of September. All right, we will go straight away into problem one. Guys, welcome. I'm sorry, I should have welcomed all of you to this class. We are coming towards the end of our program, and today is session 8. We are missing one, and hopefully we'll be able to catch up on that. um, but we will go ahead with session 8 today. I did send the questions and the problems to your session, to your center managers, and I trust that it eventually reached you. I sent it, I think, last week, Wednesday or Thursday, and I trust that all of you had a chance to have a look at the questions. Once again, I will remind you that there is no point in getting the answers without even trying the problems. Mathematics problem solving is a very exciting and a very beautiful occupation, um, especially when you have very creative solutions. And, and the power of mathematics comes into play to solve problems which sometimes are seemingly impossible. All right, so let's get on with the work at hand. The first problem is, let me just get my act together here. Okay, so just have a look at the top part of this screen. Three congruent squares of side length 16 are inscribed in a circle as shown in the figure. Find the area of the circle in terms of pi. This problem was actually in the last session, but we didn't have time to do it. And I thought it's important to discuss this. So today we are going to do quite a few problems in it, because we added one or two. So this is the first one. All right, now one of the important things about circle theorems is that if you have a circle and if you have a chord in a circle, then some interesting things happen. If I've got a chord, and if you join the midpoint of the circle to the chord, let's just draw a chord here. And if this is the midpoint of the circle, the center of the circle, to the midpoint of the chord. So suppose this is the midpoint of the chord like that. Okay, let me just indicate that it's a midpoint. So these two pieces are equal. Then if you join that point to the center, this angle here is 90 degrees. It's a right angle. The center of a circle joined to the midpoint of a chord is perpendicular to the chord. And conversely, if you did not know that this is the midpoint, but from here, if you drop a perpendicular to the chord, then it falls right in the middle of that chord. Okay, so these are two different theorems, and they're converses. So in other words, if this line here is the radius, this line that I am showing is actually this line is a perpendicular bisector of the chord, you see, because it goes through the midpoint of the chord and is perpendicular to it. And a nice consequence of this is that the perpendicular bisector of a chord always goes through the center of the circle, any chord. If you take any chord and if you drop a perpendicular bisector, it goes through the center of the circle. So these chords can allow us to find the center of the circle simply by drawing perpendicular bisectors. Like in this case here, you have two squares. They say these squares they are identical. Congruent means they are identical. It means they have the same side, right? And because they are squares, these are 90 degrees. And here it is, you've got a chord of the circle. So this chord, this is the perpendicular bisect of the chord. It must go through the center of the circle, all right? So therefore, we can imagine that the center is on this line. And I've drawn this O. I identified a point here, O, and that is the center. Okay, right. Now, the problem is, I've got the center. The problem is to find the radius, given that all these squares have got side 16. So all the sides of the squares are all 16, as you can see. All right, so how do you find the radius? Okay, now that I've identified the center to be on this line here, I can join that center to A, and this becomes radius. Likewise, I can join this center to B, which is on the circumference, so that becomes a radius. So we can see in this diagram, we've got two radii, and I'm going to calculate this radii. I don't know how far this center is from this point here where these two squares meet. So I'm calling this little distance here, I'm calling it x. This little distance here. Right? Okay. So now I'm going to get equations involving the radius. And the two right angle triangles, this right angle triangle here, and this other right angle triangle, this one here, they give you two equations, which are the theorem from the theorem of Pythagoras. So if I look at this triangle here, then the r is the hypotenuse of the triangle. So r squared is equal to 16 squared, right? That squared plus this squared. Now this distance here from there, I've got a small part here, which is x. The whole thing is 16. So just this part here will be 16 minus x. So the other side of the triangle is 16 minus x all squared. And then that is from that triangle. But from this other triangle, we can calculate the radius again the same way. But now this is a right angle triangle. This time, one of the sides is this. Okay. Now, this point here, where did this point come from? I've actually taken this and lengthened it to hit this bottom line. And I can see it has to be perpendicular because these two lines, this is a square, and these two lines are parallel, right? So therefore, this line here is perpendicular, and that tells me that this, because I joined it to the center of the circle, as I just told you now, these two pieces are now equal, because if you join the center of a circle to be perpendicular, equal. So this whole length here is 16. So this part here must be 8. So I've got one of the sides of this right angle triangle is 8, and the other side is 16 plus x because it's outside. Right. So now that gives me an equation with one unknown, namely x. Right. I'm not going to go through this, the calculations of this. It'll take a lot of time, but you can do that. And you'll see that x is equal to 3. See, when you calculate it. Now, if x is equal to 3, then we need to work out the area of the circle in terms of pi, right? So the area of a circle is pi r squared. Now we got r squared here, and now we also know what x is. So I can substitute x into this equation here, because that's r squared. That is 16 squared is 256. And if I put x equals 3 here, which can calculate, you get 13 squared, which is 169. So pi r squared is pi into 256 plus 169, and that is 425 pi. So the area of the circle is 425 pi. Okay, so the important thing here was to observe that the center of the circle is on this line here, and it's not equal to this. Sometimes you might be tempted to say the center is this, but it's not that, because this is not the same distance from A as from here to B. So we don't know that. Okay, so we can see intuitively it's going to be above. Okay, so that takes care of that problem. The other thing that we used there was the theorem of Pythagoras. And to eventually solve the problem. I'm going to ask everyone to take your microphones off, please. Somebody has got the mic on. Please take it off. I'm trying to get my... All right. The next problem. This is quite a tricky problem. And I'm not going to spend too long over it because it can be quite time consuming. All right, you've got a product of several numbers. Let's say how many numbers there are in this. If you want to count how many numbers, you take all the odd numbers, starting from 1 and ending at 99, and you want to find out how many factors there are. It's hard to count it like this, but there's a nice trick that I use. Instead of counting this, I'll just count the even number next to it. 2 times 4, 6, 8, up to 100. I add 1 to each one of them. This I can count, because these are all the multiples of 2. And if you divide every one of them by 2, you get 1, 2, 3, 4, all the way up to 25. I'm sorry, 50. So that tells you that there are 50 numbers, because there are 50 even numbers. Therefore, there are 50 odd numbers. The 100 numbers are divided up into 2 equal parts. We could have done it that way as well. All right, so there are 50 numbers here. Just bear that in mind. And now they ask you, when you multiply all these, what is the second last digit of this product? It's a huge number. So the question is, what is the second last digit? I can see what the last digit is, because it must be a multiple of 5. So the last digit will be 5. It's a huge number because you're multiplying all these 50 numbers together. It has to be 5 because it either is 5 or 0, a multiple of 5, but it can't be 0 because there are no even numbers here. So if there was an even number, then 5 times that even number will end in 0. So this ends in 5. But more than that, it's actually a multiple of 25, because one of the odd numbers that this product hits is 25, somewhere along the line. So this is a multiple of 25. Because you got a lot of numbers multiplied together, and one of them is 25, so it's a multiple of 25. Now, the multiples of 25 are 25, 50, 75, 100, 125, and so on. And you can see quite clearly that we've got an odd multiple of 5, so it's either, it ends in either 25 or 75. So we are getting there. So this number here, this number here, let's call it x or something. X is either 7 or 5. I'm sorry, either 2 or 7. Yeah. or 7. Now, which one is it? It's going to be, we've pinned it down to only 2 numbers, but now the question is, which one of these is it? And this is where the difficulty comes in, because this is not easy. The thing about 25, I suppose if you do lots of problem solving, you'd be able to zone in on this technique here. You see, these are the last 2 digits. And there is a rule, a division rule, which involves the last 2 digits. That division rule is divisibility by 4. Divisibility by 4. Now, you know that if the number ends in a multiple of 4, like 24, then this is a multiple, this entire number is a multiple of 4. But this number here, if it ends in 25, if it's 25, then the multiple of 4 will be just 1 below that. The remainder, let's call this n. The remainder when n is divided by 4 is 1, right? And in the other case, 75, this is 72 plus 3. I'm taking the closest multiple of 4. 4 times 18 is 72, and is 1. And if 75, the remainder is 3, right? So the question is now, when I multiply this large number here, but when I divide the large number, rather, by 4, what is the remainder? Is the remainder 1 or is the remainder 3? So that becomes the problem. Okay. By the way, you instead of 72 plus 3, I could have said 76 minus 1. The next multiple, 76 minus 1. So here the remainder, when I just take the remainders, this remainder is 1 divided by 4. And I'm going to say this is 4 minus 3, right? 4 minus 1 at least. So it's a multiple of 4 minus 1. Multiple of 4 plus 1. This is multiple of 4 plus 1, multiple of 4 minus 1, because this is 8 minus 1. Now you see a nice pattern emerging here. So when you are dividing all these numbers by 4, you will see you get a multiple of 4 plus 1 or multiple of 4 minus 1. And at the end here, this thing here is 100 minus 1. So it's minus 1 and plus 1. Now these are the remainders. Each of these numbers here is of the form 4k plus 1 or 4k minus 1. We are saying it's a multiple of 4 plus 1 or multiple of 4 minus 1. And when you multiply numbers like this together, these two numbers, right, when you make the calculations, you will see it becomes a multiple of 4 minus 1. Only the product here is this. So you got 4k plus 1 into 4k minus 1. Right. When you multiply these two, it's a multiple of 4. Multiply those two, it's a multiple of 4. And multiply those three, those two, it's a multiple of 4. So you have a multiple of 4, let's call it 4L. And then the last one is plus 1 minus 1 minus 1. So in other words, all these, when you multiply all of them, you get a new number, which is 4L plus, now you multiply all these constants here, plus 1 minus 1. And there are 50 of them, because there are 50 terms here. So you got 50 numbers which are either +1 or -1. And if you, and the first one is 1 minus 1, 1 minus 1. So you can multiply in pairs, and you got 1 times -1 is -1. So here, when you multiply all these things together, right, you get 1 times -1 is -1, and there are -25 of them because there are 50 altogether. There are 25 negative ones because you got, if you pair them together, the product is -1, and there are 25 such pairs, and this is definitely -1. Right, so in other words, this product here, right, when it is of the form 4L minus 1, which means that it's not this, but is this one here, because this is these numbers 75 and is of the form 4L minus 1, 76 minus 1. So therefore, ends in 75. And the second last digit is 7. So the answer is 7. Okay, now that's quite a mouthful. Okay, hopefully you have time to go over this and try to understand it. It's a, as I said right in the beginning, it's a tricky problem. I suspect that that's going to be the most difficult problem that we're going to do today. So don't feel too depressed that we are going to continue in this strain. All right. The next problem, 3 prime numbers. So it's given that x, y, and z are all prime numbers. They satisfy some equations. Let's write these equations down. First equation, xy plus xz. Let me take out x as a common factor. Xy plus xz is 80. And the second equation is y, x, I got y is common here. So it's y into x plus z is 425, 425. Okay, so you've got 2 equations, and these 3 numbers are prime numbers. Now that's very useful. So, because now this means that you've got 2 numbers multiplied together is 80, and one of them is x. So x is a prime factor. It's a prime number. It's a factor because x times something is 80. It's a prime factor of 80. And when you work out the factors of 80, that's 10 times 8. And 8 is 2 cubed. 10 is 2 times 5. So this is 16 times 5, which is 2 to the 4 times 5. So the prime factors of 80 are only 2 and 5. Right? So you get x is 2 or 5. And likewise, y is a prime factor of 425. 425 is 25 times 17. How do I know that? Because 25 times 4 is 100. So it's for 400, it'll be 25 times 16. And this is one more 25 to that. So this 25 times 17. And that tells you that y is either 5 or 17. See? So now you need to know what x and y are, right? And yeah, you got 2 possibilities in each case. So we haven't zoomed in on what xy is. But let's just take out all the possibilities and we write down the pair xy. What is the pair equal to? X could be 2 and 5, or 2 and 17, or 5 and 5, or 5 and 17. So x could be 5 and y could be 17. So these are the only 4 possibilities for x, y. I need to find out which one is it. Right? Now, I can eliminate this one here because they said that there are 3 prime numbers here. So here, in this case, x and y are both equal. So that can't be the case. There are 3 prime numbers, not 2. Okay, so you'll have this situation. Now, you can take each one of them and try to see whether you get this. For instance, now, in this case here, if I got x into, oh yeah. So here, if xy is 2, 5, so you can see, then if I substitute, I get 2 into y is 5 plus z equals 80. And that gives you z. 5 plus z is 40. And z is 35. And that's not prime. So you can eliminate this guy. See? Like that, now you can substitute these two and these two. And I suspect that these two work. Not this. This doesn't work. So let's try these two. You get x into y plus z is 80. See, I know I've got 2 numbers here, so I can work out the third one. Right? By just substituting these 2 numbers. X is 2 and y is 17. In this case, I'm trying this one here. Plus z is equal to 40. And you got 17 plus z. It's 40 divided by 2. It's 20. And z, no, it's 8. It's 80. Right? And this is 40. And z is 40 minus 17, which is 23. Oh, that's fine. That's a prime number. But let's just check to see whether the other things is satisfied. Y into x plus z. Y into x plus z is, in this case, y is 17. And x is 2. And z, we said, is 23. This is 17 times 25, right? Okay, that's fine. So this is the answer. And z is 23. So you got x, y, z now. This is the only pair which will work. All the others don't. It will be 2, 17, and 23. And the question is to calculate 5x plus 2y plus z. And you can substitute these things. Now, I've written my answer right there in the corner there, so that I don't have to waste my time calculating the simple thing. Just substitute and you get your answers. Okay, so that takes care of problem 3. Okay, let me pause here for a moment and ask if there are any questions, any issues that you want to raise. Okay, so there are no questions so far. We'll proceed. Let's go to the next problem. Step 4. You can just ignore this table for a moment. Now here you got the mathematics competition consists of 30 multiple choice questions. Okay, now you know that kind of scenario. You have that kind of situation even in the Olympiads. And there you have either 25 or 15 multiple choice questions. So you got 30 multiple choice questions. Now, 4 marks are awarded for a correct answer. So the answer is correct. The 4 marks is awarded. And for the wrong answer, -1 marks are given. In other words, if a person guesses, there's a punishment for it. Okay? This kind of thing is quite common because people don't want, sometimes by a guess you can get the right answer and get 4 marks, which is very unfair. So there's a penalty. If you get a wrong answer, yeah, they get -1. So if you don't know, you rather keep quiet. You don't answer at all, and you'll get neither -1 or 4, right? Which is better than getting -1. Okay, so that's the situation. Now the question is, what is the minimal number of participants needed to be sure that two of them will have the same score in the competition? Now that is quite a mouthful, all right? They ask, what is the minimal number of participants needed to be sure that two of them will have the same score? So let's take some possibilities. Suppose minimal, just to understand the question, minimal number of participants is, say, 10. Right. Now, you got 10 participants. Now, can you be sure the two of them will have the same score? Now, if you got 10 participants, you can have, for instance, they could be answering, every one of them gets 9 right. Right? So, oh, I'm sorry. You can get, for instance, you get 1 right and don't tackle anything else. So you'll only get you get 4 points. See? You get 1 right and all blanks. You get 4. Or you could have 2 right. Or you could have 3 right. And so on until you come to 40. So you could have these 10 scores. These are 10 possible scores. And you can also have a score of, oh, okay. And here there are 10 scores, but no two of them are the same. No two of them are the same. So with 10 can't be minimal, right? Because it's quite possible to get 10 different scores. So the question is now, is it possible to get like 30 different scores? Will give you 120, right? So, no, I'm sorry. The maximum score is 120. Now let's see what are the scores? Okay, before that, so suppose there are 1,000 students. Now, I think in that case, you can be quite sure the two of them will get the same answer. Right? So 1,000 will work. I don't even have to try it because you only got 30 questions, right? So you can't get 1,000 different answers. Okay, actually, the number of different answers is what? Number of different scores. The possible scores are right. In extreme case, a person can try to guess all 30. He guesses all 30 ones, and for each one of them, he gets -1. So you can get at the extreme cases, you can score -30. Or you can guess 29 of them and leave 1 blank, and so on, right? And the highest possible score you can have is when he gets all 30 right, which is a very happy state of affairs. You can go up to 120, okay? So the scores range from -30 to 120. And how many possible scores are there? Number of possible scores. If you go all the way from -30 to 120, you've got a 0 is also one of them, where he doesn't answer any one of them at all. He just sends a blank paper. So that gives you 120 on the positive side, 30 on the negative side. That's 150, include 0, and you get 151. So there are 151 possible scores, which means that if there are 152 participants, you must get two of them having the same score. I'm going to repeat that. So we know the number of possible scores is 151, right? So if you got 151 people participating here, 151, you can have 151 different scores. But if you have 152 participants, there's no place for the 152nd score to be put in. All 151 are occupied. So the 152nd score will have to be one of the ones which have already been counted. And that will make two of them have the same score. You see, so if there are 152 people, then it'll work. So one of the possibilities for the number of participants is 152. Now I'm saying one of the possibilities, and that is because I don't know if all 151 scores are possible. See, I don't know whether all 151 scores are possible. So that is what I've done here on this table. I'm trying to see which scores are possible. Now, suppose now I'm calling A is the correct ones and B is a wrong one, and here doubtful. You don't no answer, right? So if you got 30 questions, so it's possible to get 30 right, in which case you'll have to have the others both zero, and the score is 120. These are the scores. Right, now I'm going to take all the possibilities. If there are 29 correct, then you can have 10 or 01 to make up 30. And these will be the scores, 115 and 116. I'm not going to calculate it, but you can check it out. Now, if you got 28 correct, then you could have two incorrect and no guesses, one incorrect, one guess, or none correct but two guesses, in which case there are three possibilities here, and these are the scores that you can get. All right. So like this now, I calculated all the scores of 27, 26, and so on, and I noticed that at the bottom rung, I've got, for instance, like 101, 102, no, I'm sorry, 102, 103, 104, and I got 105, 106, 107, 108, and 109 is missing. See? But down here, I've got every four numbers, one after the other, are at what I call attainable. You can create this. Because at the bottom you've got 26 correct, but you've got enough to play around with to get up to 30. See, like here, you didn't have enough to play around to get to, for instance, you got 29. You don't have, for instance, to get to 118 or something, you needed to have more numbers here. All right, so all these numbers from down here are attainable. I can prove it, but that'll take time, and I don't want to do that. But we can just see from this table here that all these numbers are attainable. Every four consecutive numbers are attainable. Four consecutive numbers. Okay, very quickly, I can tell you how I do that. Four consecutive numbers will be of the form a multiple of 4, 4a, 4a minus 1, 4a minus 2, 4a minus 3. Right? And then the next one can be a multiple of 4, because 4a minus 4 is a multiple of 4. So you can write a number like this. Just take the nearest multiple larger than that, and this will be 1 or 2 or 3 removed from that number. Right? And all these can be obtained, because this is a will be 4 here, and the B's will be 1, 2, or 3 because these are the negative ones. And then you need to know how many zeros there are, right? And you will see that as long as A is less than or equal to 27, we can find a positive C. C needs to be a positive number. Right? All these are positive integers. Right? But if it's less than 27, you can find it. But you can't necessarily find it when A is 28, for instance. See? Because if A is 28 and A is 3, A is 28 and B is 3, that makes 31, you see. So you got too many. You can't find the C. Okay, so this is really the trick. So that is why the cutoff point is 27, as you can see. And this tells you that no matter which ones, you can always find it. Right? So all these numbers are attainable. Okay, that's a little bit tricky, but try to think about that and see. Now the question is, we still don't have the answer to our problem. So let's just, the only thing we have to do is to find out which numbers are not attainable, because we want to count out all the different scores. Now you can see here, 120, I've got 115, 16, 17 is not, 18 is not, 19 is not. These are not attainable. Not attainable numbers. Right. Then you got from the next lot is 119, so 116, yes, 115, no, 114, no, 113. Yeah, you can't find 113 as well. 113, no. So 112, yes. 111, yes. 110, yes. 109, no. Right? You can't see 109. But from 108 downwards, everything is there, as we saw. So there are how many numbers? 3, 7. There are 7 numbers which are not attainable. No, 115, I should include 115 is there. Right. Okay. So there are 6 numbers. 6 are not attainable. 6 of 151. Sorry. We had 151 possibilities are not attainable. All the others are. 145 are all attainable. And that's the lowest because those are the only ones which are not attainable. So therefore, you got 145 different numbers, different scores. And if you want 2 of them to have the same score, then we must have at least 146 participants. See, 152 will work, but that's not the minimum. The minimum is 146. That is why we had to do all these other things here, because there are 145 different scores. If you had 145 participants, you can get 145 different scores, because each one will have a different score, but not with 146. Okay, so that takes care of that problem. That was quite a tough problem. Okay, so let's these questions questions are taken from advanced papers, junior round 3 and team competitions and all that. So that is why I didn't want to give you some of the simpler questions which occur in SAMO round 1 or even round 2, right? We wanted to challenge you, we want to prepare you for round 3. So therefore we had to give you tricky questions. Okay, so let's get on to the next problem. Each problem has got a solution, and you just understand the strategy. Like here in this last problem, you got a minimum number, and no two are the same, and so on. You try out small numbers, and you see, okay, whether it works or whether it doesn't work, and then you ask yourself, why does it work and why doesn't it work? And then you see that certain answers come out. Like in the last one, we saw that we need to have 100. You need to know how many different scores can you get altogether, right? That would have answered the question, right? Not the question about whether two people have the same score or not. It's the same as asking how many different scores are there altogether, right? And we found out that there are 145 different scores, and that will lead to the answer. So you have to, that's the strategy to solve those kinds of problems. So each time you have a way of these solutions here will give you an idea as to how to solve problems which are differently set. But unfortunately, there are so many types of problems, you can't do all of them. In every case, you have to think about it and use your logic and try to work out. Right, so now in this problem here, you got 3 balls which are marked 1, 2, and 3, and you are asked to, they are put in a bag. A ball is drawn at random. So you get a bag and you got 3, right? And they are marked 1, 2, 3 like that, right? Now a ball is taken out at random. Say, suppose you take out 3, then you're left with 1 and 2, right? So its number is recorded. So I just recorded the number. And then the ball is returned to the bag. Oh, so this 3 goes back into the bag. So you're back into that situation. And then this is done 3 times. So I take out the ball again. So I could take out the second time, I can take out 2, for instance, put that back. And the third time I can take out 3 again, because all 3 are there. So this is a sequence that I can get. The first number is 3, the second one is 2, the third number is 3, right? After I play it once. Now, this is done 3 times. And each ball is likely to, okay, so you play this game 3 times, in other words, right? You play this game 3 times. So this is the first game, or I'm calling it a game, game 1. You got game 2, game 3. Now, how many possibilities are there altogether? That is this thing. So you got 3 draws, and in the first, the first draw can be any one of 3 numbers, right? The second draw, any one of 3 numbers, and the third draw, any one of 3 numbers. So therefore, in any particular game, you've got 27 possibilities. And if you write down a whole lot of them, you'll get 111, 222, 333, 112, 131, and so on. You can write down 27 different possibilities. Each one can be done in 3 ways. Right. Now, what is the probability that the sum of the numbers on the three balls drawn, if you take these 3 balls, is 6? Right? You've got 27 possibilities. What is the probability What is the probability that the sum is 6? Okay, now you could have 1, 1, 1, 1, 2, and so on. Right. Now, if you want a sum to be 6, it has to be 1, 2, 3. That's the only way you can get 6. Or you can get 2, 2, 2. All the same. Right? Or you can have 1, 2, 3. But 1, 2, 3, it could be 3, 1, 2, or 2, 1, 3. So actually there are 6 different ways in which you can arrange this one here. Right? There are 3 factorial ways in which you can arrange 3 numbers. So any one of these will give you a score of 6. And there are no other combinations will give you a score of 6. So there are only 7 ways in which you can get a score of 6, and the total number of possibilities is 27. So therefore, the probability that the sum of the numbers is 6, the answer is there are only 7 chances in 27, right? So the probability of picking a 7 is 7 out of 27. Okay, so that takes care of that problem. Okay, so we go on to the next problem, question 6. Okay, we finished question 6, so we go to question 7. Right here, teams A and B are playing a series of games. Kosinati, you raised your hand. Can you? I'll take this
Say
question.
skip the question. Say skip
Yeah.
question 5.
Oh, I skipped question 5. Okay, thanks for telling me. Thanks for telling me, Kosinati. This question 7. Oh, this one. Okay. Thank you for letting me know. Okay, so here you got 3 of the numbers 1, 2, 3, 4, 5 are chosen at random and then arranged in increasing order. Right. Now, what is the probability that the 3 chosen numbers are consecutive? So you got 3 numbers which are chosen at random, but they're put in increasing order. Okay. And the question is, what is the probability that the 3 chosen numbers are consecutive? Okay, let's look at all the possibilities. I take 3 numbers, right? So I could have had, I can't take 1, 1 now because you would take 3 of these. Right? So you could have had, say, 1, 2, 3. Right? Let's work out all the possibilities. You got 1, 2, 3, or 1, 2, 4, or 1, 2, 5. Those could be 3 numbers where you got 1 and 2 are included. I could have had 1 and 3, then 1, 3, 4, 1, 3, 5. I could have had 1 and 4, 1, 4, 5. And this takes care of all the ones which start with 1. Or you could start with 2. It's an increasing order. So you put 2, 3, 4, 2, 3, 5. Okay, so you could have 2, 3, 4, 2, 3, 5. You could have had 2, 4, 5. Right? And that takes care of all the 2s. Then starting for 3, there's only 1 which starts with 3 in increasing order. It's that. Okay, so the total number of possibilities is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 possibilities altogether. And then you want to know what is the probability that the 3 chosen numbers are consecutive. Okay, these are consecutive. Not here, not here, not here, not here. Yes, here. And the last one. Right? None of the others are consecutive numbers. They must be all next to each other. So the answer is, well, the probability, actually. They ask you, what is the probability? You only got 3 successes out of 10. 3 out of 10. And it's written, it's P over Q. So in lowest terms, this is already in lowest terms, so that's fine. So here you have P must be equal to 3 and Q is 10. And the question is, find P plus Q. Always answer the question. You know, I've been doing some moderations of your answer scripts and notice that people don't answer the questions. You know, they look at the thing and they eventually write down an answer, but the answer does not correspond to the question. You must answer the question. So I'm sure many people will stop at 3 over 10 and stop there. But the question is, find the value of P plus Q. They didn't ask you what's P over Q. So you'll lose marks if you do that. All right, so that takes care of question 5. The next question is, okay, we can go to question 7. Yeah, I think this was the one that we went on to. Okay, so you got teams A and B are playing a series of games against each other. All right. So I don't know what games they have, probably soccer or whatever. So suppose they're playing soccer against each other. The probabilities of either team winning any game are equal. All right, so this is, in other words, these two teams they have got the same strength, right? So if you follow English soccer, Arsenal and Liverpool are numbers 1 and 2 at the moment. So they probably got the same strength. Now the probabilities of either team winning any game are equal, right? Either team A must win 2 games or team B must win 3 games to win the series. Okay, so they're playing a series and if A wins 2 games, it wins the series. And if B wins 3 games, it wins the series. Right. So, okay, that's fine. Now, if the probability of team A winning the series is expressed as x over y, calculate the value of x plus y. Now, look, there is some doubt about this thing here. But my answer is different from what was put in, was publicized, and I'm going to stick to my answer. You see, if 2 teams are playing, I can safely assume that as soon as team A, for instance, wins 2 games, then the competition is finished. You don't have to play any more games because then you both agree, right? A wins, right? Or as soon as B wins 3 games, if it wins 3 games before A wins 2 games, then you stop playing. Right? But the people who gave the answer, they said no, all 4 games have to be played, and I found it quite difficult to accept that if A wins 2 games, first 2 games, and then why should you continue to play to decide who the ultimate winner is? A has already won, so it's just a waste of time. All right, so I'm going to use that now as soon as one of the teams wins. So suppose now we count, we say we count all the wins. Suppose we got A wins the first game, the game 1. Game 1, game 2, game 3. All right. So suppose the first game, the winners are. I'm only going to write the winners. Suppose A wins game 1 and A wins game 2. Then you stop. That means A as wins the series. Right. Okay. You could have had A win the first game, but B win the second game. So there's no conclusion here. But you can have A winning the third game, in which case you stop because A has won 2 games. Or you could have had A and B winning the second game, and you could have had B winning the third game. And still there's no decision. But if A wins the fourth game, the game stops. Or you could have had A, B, B, and you could have B. So I've got B, B, A, B, 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 taking care of all the possibilities. So I could have had that when A wins the first game. Right. If B wins the first game, then I will have BA. That doesn't stop me from continuing. I could have had BAA, right? Then we stop there. Or you could have had, let's go here. You could have had BAA, or you could have BAB. It doesn't stop there. But if I had an A here, that stops. I could have had BAB, and if I had a B here, that stops. Because you got 3 Bs. See, if B wins 3 games, then B wins the series. So A wins the series here. Now, you could have had B, instead of BA, now you could have had BB. B wins the first 2 series, and the fans are delighted. You want to just win 1 more game, and A wins that. So no decision. And A wins the next game as well. The fans go home crying because despite the fact they started off well, didn't work. But this time, the last game, B wins it. They're all very happy. And then you could have had BBA, or you could have BBB. Right? And this time, B just walks away with the crown. So you've got 10 possible games altogether. Right? And A must, what is the probability of team A winning the series? So here A wins, here A also wins, not here. A wins here, but there are 2 A's, 2 A's, 2 A's, and in all the other cases, you got 3 B's. So there are 6 times out of 10. 6 times out of 10, the probability is therefore 6 over 10. Probability of A winning the series is expressed in simplest form as 6 over, but this is not the simplest form. It has to be 3 over 5. Right? So you want, so X is 3 and Y is 5. So this is 8. Why do they have to say simplest form? Because when you go to a ratio, there are many possible values for X and Y. So given a ratio X over Y, you can't say X is 3 and Y is 5. It could be X is 6 and Y is 10. Right? There are infinitely many ways of writing a fraction. You can multiply the top by any number you like, and as long as you multiply the bottom by the same number. But there's only one simplest form. Right? When you take out all the factors from the numerator and denominator, so they don't have any common factors, which is the same as saying the highest common factor is 1, then it's the simplest form. All right, so let's just, that takes care of question 7. Okay. Now, how many Mara just entered this? Allow her to come in. Also, I don't know why people come in. It's 7 minutes past 6. Well, at least it's taken an interest in coming. Okay, maybe while she was coming here, she was trying to avoid all the potholes. There was a puncture. Anything can happen. Okay, the next question here is, now these are probability questions, and you can see I'm working everything out from first principles, no formulae, but just pure logic and trying to understand the question and try to work out all the possibilities. The most important thing is to find out all the possibilities, total number of possibilities, and then you find out which ones are successes. Like the last one is success will be when for A to win, right? So we count all the cases where A wins, right? And in the other case, the successes where the sum is 6. You count all the successes and you put it over the total number of possibilities, and that is the probability, right? So that is how we work with probability. But in all cases, we count. We try to count them or list them and get an answer. So this next question here, I don't think this is a probability. I think maybe there is a bit of that. A jury of 12 people has to decide whether a person is guilty or not guilty. All right, so you got 12 people sitting in judgment over somebody. And now how do you decide? Because people have different opinions. And some people might say, yes, guilty. Another person will say, not guilty. So how do you make a final decision? So it says here an absolute majority. Right? You've got 12 people. So if it's 6-6, then it's not an absolute majority. Right? It's a drawn case. They probably have to go back and decide again. But a majority, you need to have 7 people to say the same thing. 7 people to say not guilty, then that becomes the verdict. Or 7 people say guilty, and that becomes the verdict. Okay. Now, it is known that 4 will say yes. So 4 of these jury people will say yes, and 3 of them will say no. That is known. So you got 7 altogether. So you don't know about these guys. The 5 of them, A, B, C, D, E, let's call it. You don't know whether they will say yes or no. Okay. Of the rest, 4 will toss a coin. Oh, God. So this is how they will judge whether a person is going to be hanged or not. They toss a coin. And you've got 4 of them. So imagine some of these they all toss a coin. So they will decide. I'll toss a coin. If it's heads, yes. Tails, no. And after having done that, they will put in their judgment. So either yes or no. So it's heads or tails will decide whether it's yes or no. Each one will decide on whether it's yes or no according to his heads or tails. All right. Now, the thing is, when you toss your coin, you'll have either heads or tails. So you could have had all heads, or you could have had all tails. There are lots of things in between. But now this is where accounting comes in, because when you count four tossing of the coins, you got, how many do you have altogether? You have HH, and here you have HT, HH, you have TH, you got HH, you got TT. So with 2 H's, you got 4. Like that, altogether, if you work it out, you can see quite clearly you're going to get 16, because you can have HT in the front, so TH, or you could have had HT, or you could have TT. But the best way is, the first one could be chosen in 2 ways, this one here. The second one can be chosen in 2 ways, that one. The third one in 2 ways, and the fourth one in 2 ways. Can be any one of H or T, and that gives you 16. So there are 16 possible outcomes for these guys here, right? Now, Now this E, what happened? What about the last guy? The remaining one will vote with the majority. Oh no, this will, you will vote to the majority. You will see, if there are more yeses than noes, then you'll say yes. If there are more noes than yeses, you'll say no. Right? So he's votes as the majority. It's like what they do in parliament. And people just vote to the majority, even if they don't understand what the issue is. They just see what their friends are doing, they put their hands up. A lot of voting takes place like that. Anyway, so this guy, he votes to the majority. Now let's have a look at this thing. Now you got 4 yeses. Now, if one of these is a yes, then you got 5 yeses and 6 no's. So that's not a majority. Right? You want to find out whether he is guilty. So what is the percentage that the faction will find guilty? So you want to count how many yeses there are. Yes is guilty, right? Now, if one of these says yeses, then he's not guilty, because then you'll have 5 Ys and 6 no's. 11 altogether voting. This guy is waiting, and he will say no, and that becomes not guilty. But if you have 2 of these are Ys, yeah, then you got 6 Ys and 5 no's. So we need to count whether 2 of these are the same. And of course, if 3 of them are the same, or 4 of them are yeses, then now, so if 2 of them are yeses, then you got 6 Ys and no no's. And this guy here will say Y, because the Ys are in majority, you see? So that will make 7 Ys. So if there are 2 Ys, 2 yeses amongst these, like if you got this one, no, yeah, here, you got 2 H's and 2 T's, then you will have, it's in favor. So you're going to have 2 out of these can be the same. Now if A, B, C, D, and you got 2 of them are the same, you got yes, no, 2 of them are the same, then 2 Ys, in other words, right? Now, how can you choose? Any 2 of these can be Ys. So you're going to have AB, say 2 YY, AC, AD, YY, or BC, BD, or CD. There are six possibilities where you can put 2 Ys in 4 spaces. Okay, we've looked at those kinds of problems before. So there are 6 cases for 2 Ys. And for 3 Ys, you'll only have 4. Because we'll have 3 Ys, but you'll have only 1 no. So the 1 no could be here, it could be here, it could be here, or it could be here. So you'll have only 4 possibilities where the no is. Or you could have 4 Ys. And there's only 1 case where you got all Ys. So in all these cases, there's a guilty verdict. Guilty as charged. Let him be hanged. Okay, so there are 11 of these 16 possibilities where the fellow is guilty. Right? So the probability of a guilty verdict is 11 over 16. See? All right, so in 11 cases, you'll have 2 or more. Okay, so that takes care of that. I should have, instead of putting HT, I should have put Y, YN. Right, so that's The tossing of the coin will decide whether it's Y or no. All right. And then it would have been a little bit clearer how we get 7 Ys. Okay. Let's now just get on to the next question. And then the next question is a question in geometry. Well, not quite. Yeah, it is maybe a question in geometry. Points A and B divide the quarter circle arc. Okay, now it's just a quarter circle arc, and the radius of the quarter circle is 1. So I've got this OC is 1. That's the radius. And they divide it up into 3 equal parts. So all these parts are equal, which means that these angles that they subtend at the center, the angles that they subtend, you call them subtend. This arc subtends the angle at the center, and this arc here subtends the angle at the center. That's the angle. So all these angles will be equal, and it's 90 degrees altogether. So all of them will be 30 degrees. Okay. Now from A, perpendiculars are drawn. So you got a perpendicular here, you got a perpendicular here. Okay. If the radius of the quarter circle is 1, okay, we've already seen that. What is the area of trapezium ABB prime A? What is it? A, B, B prime. Oh, so this is the trapezium. There is a trapezium here. All right. So you need to calculate the area of the trapezium. So let's just shade in the trapezium. So I want to calculate the area. It's a trapezium because the opposite sides are parallel, but AB is not parallel to this. So the area, we know the area, the formula for the area of a trapezium. The area is, that's the question. What is the area of the trapezium? It's half the sum of the parallel sides. The sum of the parallel sides, so it's AA prime, is one side, plus the other parallel side is BB prime, and times the height times the distance between them. Now the distance between them, you can see it quite clearly, is A prime, B prime. So we need to calculate these 3 lengths, okay? Now, let me just tell you something interesting here. And just try to remember this, what I'm telling you. It's quite a useful thing about right angle triangles. Suppose I know the hypotenuse, h, and if I know one angle, right? This one here is always h times sine of theta. Right? What's the reason for that is, if I call this y, sine of theta is opposite over hypotenuse, so it's y over h, right? I think all of you know about that. And then you have that you can make y the subject, so y is equal to h sine theta, right? So that's this. And likewise, the other side is h cos theta. The other side is h cos theta. So the adjacent is h cos theta, and the opposite is h sine theta. Now, bearing that in mind, I can work out the coordinates of A. Right, now watch carefully. Coordinates of A, The x-coordinate is that. Now that is a side of the right angle triangle, that one there. It's the adjacent side. Hypotenuse is 1. So it's 1 cos 60. Adjacent is cos. The cos of this angle here. Now that's the x-coordinate of A. And the y-coordinate is that one, AA prime. And that is opposite 60 in this right angle triangle. So it's 1, I'm not going to put the 1 there, I'm just going to put 1 sine 60. From here now, it's h sine theta, h is 1 and theta is 60. Okay, so that takes care of the two coordinates of A. I'm just going to wipe this one out. And then likewise, I can work out the coordinates of B. In that case, I've got this B, I've got this right angle triangle here, BOB prime. And the angle in question is 30, and the hypotenuse is 1. So you'll have cos 30 sine 30. Okay, so these are the different coordinates for this. So now we can actually calculate these sides which we had here in the area formula, right? Because the area is a half. Now, AA prime is the y coordinate of A, and the y coordinate of A is sine 60. So AA prime is sine 60 plus BB prime. Now BB prime is the y coordinate of B, and the y coordinate of B is sine 30. Okay, that's AA prime plus BB prime. And then, and you're going to multiply this by A prime B prime. Let's just write down A prime B prime here. Now A prime B prime is that one. Now that is not the y coordinate of anything or x coordinate, but it certainly is that length minus that length. And this length here is the x coordinate of B, see? So it's the x coordinate of B, which is cos 30, that minus this one. And this there is the x coordinate of A, as you can see. So it's minus, and the x coordinate of A is 60. Cos 60. All right, so we need to multiply these two things. So remove these to create some space here. So put this down here, you get cos 30 minus cos 60. Right. Now you got four different ratios here, but if you look at the sine of 60 is the same as cos of 30. Right? Sine of an angle is equal to the cosine of its complement. So sine of 60 is cos 30 plus sine of 30 is cos of 60. I'm converting everything to cos because I've got two coses here. So sine 30 is cos of 60. And this is cos 30 minus cos 60. And here you see I've got cos 30 plus cos 60 times cos 30 minus cos 60. And that's very nice because that's the difference of two squares. A plus B into A minus B. So this is cos squared of 30 minus cos squared of 60. There's a half outside. Okay. Now, you're not allowed to use tables or your calculator. Cos of 30 you're supposed to know. Cos of 30 is the square root of 3 over 2. You square it, you get 3 over 4. Cos of 60 is a half. If you square it, you get a quarter. So 3/4 minus 2/4 is a half. Half times half is a quarter. So the answer to this question, the area of this trapezium is 1 over 4. Nice answer. Right. There's a little bit of trigonometry involved here, and a little bit of coordinate geometry, but you'll notice it's just pure, really not coordinate geometry, but I'm just looking at, yeah, these points on a circle of radius 1 are very important. This kind of calculation, see, because you can work out the coordinates of any point on a circle, right? If you know the angle that it's obturned to the positive x-axis in terms of that angle and the radius. So that's an important exercise. Okay, so let's just get on to the next problem. This problem here, what is the biggest possible area of a quadrilateral with sides 1, 4, 7, 8? Now that looks like quite a, if you got a quadrilateral with sides are 1, 4, 7, 8, now you can have infinitely many quadrilaterals. See, 1, 4, 7, 8. You can 7 and 8 here. Now, so they want to know what is the largest possible area of this quadrilateral. Okay, to answer the question, how do you find the area for quadrilateral, any general quadrilateral? You only know the areas of certain quadrilaterals, like rectangles, rectangle breadth, and you might be able to calculate the area of a rhombus, area of a trapezium, and so on. But the area of a general quadrilateral you don't know. But one of the ways of doing it is divide it up into 2 triangles, because you know the area of a triangle, you see. So to do that, you draw a diagonal, like the way I've done here, and I've put down the sides A, B, C, D. I don't know what these sides are. I'm not putting 1, 4, 7, 8. I'm just going to put A, B, C, D in general, and then see what comes out of that. And then I see that once I got that, then I can calculate the area of this quadrilateral. What is the area? Because if I call this angle beta and I call this alpha, I know how to find the area of a triangle given 2 sides and an included angle. Because the area formula in trigonometry, in case you don't know, is if you got 2 sides and an included angle, right? Those people who haven't seen this before, the area, there's a formula for it. It's a half AB, the product of these two, times the sine of the angle between them, sine of theta. See? So this area here is a half, half CD sine beta plus a half AB, this other triangle, sine alpha. We don't know anything about alpha and beta. I don't say they are supplementary because we don't know it's a cyclic quadrilateral. It's just any quadrilateral. Need not be cyclic. But what we can say, they're asking for the biggest possible area. But we can say that the largest possible value for sine B, sine alpha, let's focus on that. The largest possible value for sine is 1. Sine can never exceed 1. Right? Opposite of our hypotenuse, the hypotenuse is the largest side. So the numerator will have to be smaller than the denominator. So you've got this largest value is 1. So this is less than or equal to 1. And this is also less than or equal to 1. And it's equal to 1 when B is 90 degrees. Right? Then, so when beta is 90 degrees. And this is equal to 1 when alpha is 90 degrees. And that is why I put 90 degrees pictures here, you see. I got 90 degrees. This will give you the largest area. That figure there will give you the largest area. Okay. Now, you got the numbers 1, 4, 7, 8. But now the question is, where do 1, 4, 7, and 8 fit here? And that's an interesting question. Where do I put them? Then you see, but wait a minute. This is the hypotenuse, and it's going to be, you can use Pythagoras in both cases. So it's going to be the sum of squares. So you get 1 squared, 8 squared, 7 squared, 4 squared. This is 1, 64, 49, and 16. And you want 2 of these squares. Well, I actually got the answer down here. But the sum of 2 of these squares will have to be the same, because this hypotenuse square is equal to that square plus that square, and that's equal to this square plus this square. And you'll see that you can add 1 and 64 and 49 and 16. They both give 65. So therefore, the adjacent sides are 1 and 8, as you can see. And in the other triangle, the adjacent sides are 7 and 4. And here, the area of a right angle triangle is very easy to calculate, because it's just half base times height. There is half of 8. Here is 7 times 4, so it's 14. So the area of this triangle and the area of this triangle is 14. And therefore, the answer is, the maximum area is 18. It's a nice problem. Okay, I've exceeded my time by five minutes. All right. Okay, then I'm just going to push the next problem to the next one, because the last problem is going to take a bit of time. Maybe I'll finish it off. If some of you are patient enough, you can wait for the last one. The last one is quite interesting by itself. Let's just look at the last one. It's already trying to see whether I can finish this thing in less than 5 minutes. Okay. Now here, okay, let's not go into the diagram. There was no diagram given in this problem. We had to draw the diagram, and the diagram that we get here is a triangle ABC with one line like this. You got a 45, 60, and 30. 3 angles are given, and they don't give you any sides whatsoever. See, the only 3 angles are given. But what they do say is that ED, this thing here, it divides the triangle ABC into 2 parts of equal area. These 2 parts have the same area. In my diagram, they don't look the same, but you have to draw this E and D in such a way, maybe like that, so these 2 areas are the same. But that is the same as saying that the area of this triangle here is half the area of ADE is equal to half the area of ABC. If you got the equal areas, then it means that each one of them is half the area of the whole thing. Now, these are areas of triangles, okay? So we know the area of a triangle is half the product of 2 sides times the sine of the angle between them. But unfortunately, you've got in this triangle here, I've got 2 angles. I don't know the side AB. I'm not given any side whatsoever. But since the answer is obviously independent of what the sides are, we can assume that this one of the sides is 1. Doesn't really matter. If you call it some other name, little a or something, you'll still get to the answer. But to make matters easy, you can call it 1, because it's a ratio, you see. Whenever you got ratios, you can always choose one of the numbers. Only one you're allowed to choose, and the others you have to calculate in terms of that. So so AB, if I call it 1, so you need to calculate AD over DB. So I need to calculate this and this. So let's just call this X, AD. So if the whole thing is 1, this is 1 minus X. All right. So now you have a situation where you got this small triangle. I need to find the area of that. And what I've got is, I got the base and I got 2 angles. So the question is, what is the area? We don't have a formula for that. So I actually said, let's try to find a formula for that, because the same thing applies to the large triangle, area of ABC. I know this is 1, the whole thing is 1, and there's 45 and there's 30 here. So it's the same formula. Whatever formula I get, I've got 2 angles and a side in the large triangle, and I've got 2 angles and a side in the bottom triangle. So given that, is it possible to find a formula? Okay, yes, we can, because what we do is, okay, let's call this say B and C. Right. The area is equal to half A times B, AB, sine alpha. Now I don't want B. I only know A, alpha, and beta. I don't want B. What is B now? Okay. Now you can calculate B by using the sine rule. And those of you, some of you would have come across a sine rule. It says B over sine B is equal to A over sine. Now, this angle here, to calculate this angle, it's alpha plus beta. You add these two and you subtract it from 180, and you'll get that angle, that question mark. Right? And we want to work out the sine of that angle. Now, trigonometry says the sine of 180 minus something is the same as sine of an angle is equal to the sine of its supplement. Right? That's a very important fact. There are quite a few like that. So the sine of alpha, sine of that angle there is sine of alpha plus beta. The same as sine of the sine of that angle. Yeah. Okay, so you can make B the subject, which means that this thing here is equal to, you got a 2 at the bottom for the half, you got A, and you got A sine alpha. Now you're going to put a B inside here. The B, what is B? B is A sine beta. If you cross multiply, B is equal to A sine beta. So I'll put an A squared here because A occurs twice. A sine beta over sine of alpha plus beta. Oh. All right. So just to rewrite this thing here, the area of this triangle, whenever you have a situation like that, the area is, I'm going to, don't have enough space, so I'm just going to take these things out and say that the area is equal to, you got a rather complicated looking formula. It's A squared sine alpha sine beta over 2 sine alpha plus beta. So you can see what it is. You say it's a half, if you like, of a squared, that side squared, and then you take sine alpha times sine beta, that's the numerator, and at the bottom you have sine of alpha plus beta. So bearing that in mind, we can work out the sine of ADE. The area of ADE is, okay, your side is x squared. The angles are 45 and 60. So it's sine 45, sine 60, sine alpha, sine beta. And at the bottom, you've got 2 sine and alpha plus beta, 45 plus 60 is 105. So that's x squared. We need to calculate x. So I'm trying to get an equation involving x. And here in this large triangle, the side area is 1. So I'm going to put a half here. This half goes there. This half is coming in here now. But you've got, at the bottom, you've got 2 sine. Now, in this big triangle, is 45 plus 30, which gives you 75. And in the numerator, right, it's going to be x squared sine x squared. Yeah, you've got 1 squared, which is 1. I'm not going to put it down. And it's sine of 45 times sine of 30. Okay. So now you can work out what x is. A lot of things cancel here, which makes life very comfortable. So you can work out what x squared is. And we see that x squared is equal to, well, these 2's cancel. Sine of 105 is the same as sine of 180 minus 105, which is sine 75. So these numerators also are equal. You can cancel that. The sine of 45 occurs twice. And here you have x squared sine 60 on the left-hand side. X squared sine 60 is, and that's root 3 over 2. That's the only survivor here. And at the bottom here, you got a 2 at the bottom, which hasn't died. And sine of 30, which is a half. So it's 1 over 2. So it's, now you see, you got x squared. You can calculate x squared. X squared is yeah, it's 1 over 2 root 3. Okay. Actually, I think this was supposed to be AD over AB. It doesn't really matter, but the answer was a nice answer. So it was not this complicated thing. So AB is 1, you see. So what we really need to do is to calculate AD, which is x. This is x over 1. And now you can see what x is. This is, if you want, you can make this thing square root of 12. Because if you put the 2 squared inside here, you get square root of 12. X squared is that. So x itself is 1 over the 4th root of 12. Because you want to work out the square root of the square root, which is the 4th root. So that's the answer to this problem here. The ratio is there. Okay, so that's the last problem that we need to do. And thank you for waiting, whoever still stayed around. I know that some of you are in grade 12, and all the best for your exams. I think your examination is starting very soon on Friday, I think. So if some of you are in grade 12, all the best for your exams. And those others, everybody else will be writing exams soon. And I wish you all the best of everything. Despite the fact that you are writing exams, you still came and joined in this class, which I appreciate very much. Okay, The last one is the assignment. I've also got that here. Assignment question. So a die is so rolled 6 times. Probability. What is the probability of rolling a 5 or a 6 5 times? So that's quite a challenging problem. And I'll just give you a hint here. You're rolling a die 6 times, so you got 6 blocks, and each one you can get 1, 2, 3, 4, 5, or 6. So the total number of possibilities you can calculate, and the successes will be you need to have the 5 at least 5 times, or the 6 at least 5 times. So there will be only one which is not a 5, right? And then you say, okay, one is not a 5, and the others are either 5 or 6. So you can calculate the probability, right? And the one which is not a 5 could be any one of these. It could be the first throw, or the second throw, or the third throw, or whatever, right? And you have to see which were that. Yeah. Okay. So that's you have to do a little bit of counting there. I'm just giving you some hints on how to do that, and all the best for that. Okay, guys. So that brings to an end session 8, which was quite a demanding one, because as we get along, we are looking at more and more difficult problems. So let's just have a look at who's here. Oh, we still got 21 people. Thanks very much for coming. And we did some challenging problems today. And at some time, maybe when you're free, even after the exams, go back to the recording and try to make sure that you know how to do them without my assistance. After having looked at the solutions, you will try to do it on your own and make sure you understand how to do it. Okay, are there any questions? All right, thank you very much for coming, and again, all the best.